All right, in this example, we're going to write the equation for the circle given the center of the circle and a point that is on the circle. I'm going to show you two different methods. For the first one, we're going to use this graph, and the first one's longer, but I think it'll help you understand the second method. So if we write an equation for the circle with the center 3, 8, and remember we call that point h, k, I'm going to go on my graph. I'm going to pick a bright color so that it shows up. I'm going to go on my graph to the point 3, 8 and plot that point. All right, so that's the center of the circle. And then we know the point -6, 2, which is just an ordered pair, an x and a y. That point is on the circle because it says the circle passes through that point. So if I go out to -6, 2, that's the point that's on the circle. And if I attempt to make the straightest line I can between these two, let's see, it's hard to use this tool sometimes. So that is the radius, and we said that this is the center. So if I imagine it like it's a fairly large circle, it's going to go off the graph. I can kind of think about what the circle might look like. I don't need to draw it in. So to go back to the form for the equation of a circle, we said we need two things. We need the center and we need the radius squared. And we have the center already. We're given the center. So the only thing we need is the radius squared. So I bet you already have in your head how we're going to do that because we're going to use the Pythagorean Theorem. So we could go back to what we did way back in August and use the distance formula, but I think it would be just as easy, if not easier, is to just use the Pythagorean Theorem. So when I make the right triangle where the radius is the hypotenuse, from the center down to the point, that vertical change right here, the leg of this triangle, well, that's 8 minus 2. So I can just do 8 minus 2 because I went up from y equals 8 to y equals 2, subtract that, and that's going to be 6 units, or of course we could just count. And then the horizontal change, so the leg that's down here, is going to be 3 minus -6. So 3 minus -6 is the same as 3 plus 6, which is 9. So when I plug this into the Pythagorean Theorem, I could say 6 squared, 6 squared plus 9 squared equals r squared. 6 squared we know is just 36. 9 squared is 81. And if I add those together, 6 plus 1 is 7, 8, 9, 10, 11. We get 117 as our radius squared. Now if we're asked to find the radius, like if you actually need to know the radius for some reason, we just take the square root. But for the circle's equation, all we need is r squared. So now we have enough information to write that equation, that it's x minus 3 squared plus y minus 8 squared equals r squared 117. Now, to be honest, that's probably the longer method. I want to show you maybe an easier method. Let's just call this method 1, the Pythagorean Theorem. All right, so there's another way to do this, and I don't care which way you do it. Pick the one that works best for you. For method 2, let's pretend we don't know the r squared value. So let's go back to just knowing the center and that point. I labeled them up here, but we said the center is HK, and this point, XY, represents any point on a circle. So when we write the circle equation like this, the x and the y in the equation should stand in for any point that's on the circle. So what we could do, instead of doing the whole Pythagorean theorem, and we won't need the graph for this either, is I could first write the center in, so x minus 3 squared plus y minus 8 squared equals r squared. The only thing I'm missing is finding r squared, but now we could substitute this xy point in for x and y. So I'm going to substitute -6 in for x, -6 minus 3 squared plus +2 for y, so 2 minus 8 squared. That's going to give me the radius squared. So -6 minus 3, or -6 plus -3, is -9. So that gets more negative. It's really important you put that in parentheses. 2 minus 8 is -6. And then we're going to square that to get r squared. Now you might notice that these values are the same as the sides that we got for the triangle in the graph. They're just negative. And it doesn't matter if they're positive or negative. That all depends on what point we're using. But when I square these, they're going to become positive. So -9 times -9 is a positive 81, just as -6 times -6 is a positive 36. And so, alas, we get 117 is r squared that way. So I personally think that second method is easier just because it's a little faster, but they're both valid ways of finding the equation of a circle when we are given the center and we know of at least one point that's on the circle.